So in this short presentation, I show how to do two-way analysis of variance. When this is just a sample data, it can be anything, but in this case, I have three variables measured in two areas, and for each variable, it has got 4 data points. It means it was replicated 4 times. I have already stated my hypothesis here to say my first hypothesis is to assume that the means in area 1 and area 2 are the same. That's my first hypothesis. My second hypothesis is to assume that the means of these different varieties are the same. Then my third hypothesis has to do with interaction, that there is no interaction between area and variety. So I've already stated my hypothesis here, so I'll move them to the side. You can do this by just inserting a text box, then you type your hypothesis. So I'll put it here, then I can use it for my interpretations. Then to do my analysis, I go to File, Options, then add-ins, just to make sure my add-ins are there. Then I go at the bottom of the screen where it says manage add-ins, then I say go. Then I select the add-ins that are available, then say okay. Then I click on the data tab, data analysis. This time I want to do a two-way analysis of variances with replication. It is the replication because for each variety it has got 4 data points. So I select 2-factor with the replication, then I say okay. So my input range is only one input range, then I have to select everything including the sample and the varieties. Then the rows per sample, to say when I look at each sample, how many rows does it have? Each sample has 1, 2, 3, 4 rows. So I enter my 4 here. Then for alpha, I want it to be at 0.05 as the significance level. Then I click on the output range. The output range is about where I want my data to appear. I want it to appear here. So I want it to be here. So I click OK. Then there is my data. The good thing about this data is that it's showing me the descriptive statistics for each area. To say in area 1, variety 1, the counts, the total, the sum, the average, and the variance. Is same for area 2. It's giving me the count for each variety, the sum for each variety, the average for each variety, and the variance. Then the totals are on the next table. What's important for me here is the analysis of variance table. So I want to pull my hypothesis so that they are closer to the analysis of variance table, so that it's easy for me to see the relationship. So another way of seeing which hypothesis is tested by which of these, it's easy because they start with sample. The degrees of freedom, remember, is n-1. So for this one is comparing the area. The sample is about comparing the area. The columns is about comparing the varieties, which is now hypothesis 2. Then the interactions, which is my third hypothesis. So for my sample, when I'm looking at the area, to say, is there any significant difference between those two areas? So I look at the factor, the p-value, and f-crit. So when I look at my f-crit and the f-value, my f-crit is way larger than my f-value, and my p-value is 0.76, which is way larger than 0.05. So it means I am going to say there is no significant difference between these two areas. So it means I'm going to say there's no significant difference between the p-value. Then when I look at now hypothesis 2, to say is there any difference between the varieties, the p-value again is 0.006. Then when I comparing my f and f crit, my f is way larger than my f crit. So this gives me an idea that there is some significant difference. Then to solidify that guess, I look at my p-value. The p-value is 0.00616. This is way smaller than 0.05. So it means there is a significant difference between the varieties, the sample my samples. Then when I go to interaction, which is my third hypothesis, the interaction, the p-value is 0.3, which is way larger than 0.05. So in this case, it means there is no interaction between the areas in the variety. So the only significant thing which I found here on my two-way analysis is that there is a significant difference between the varieties. But these varieties, it doesn't matter which area they are, there is no interaction by area, and there is no interaction between the variable and the area.